This lesson is going to take our knowledge of scales and transfer them to a new way to draw stuff. And these things are called isometric drawings. And isometric drawings are drawn, if we go down here, they are drawn to scale. And we have to look at things that are parallel in real life will also be parallel in the drawing. And they're done with lines measured at a 30-degree angle. Now, this might sound a little bit scary when you first think about this degrees, but when we draw an isometric diagram, you're given isometric paper. So it's a lot easier, and all of these dots kind of can be made to make lines at 30-degree angles. So we're going to look at that, and we're going to draw this together, and we're going to do a simple one first. It says, use isometric dot paper to draw a cube with sides that are each 3 units long. Now, in a cube, the nice thing is everything is the exact same length. And in this situation, they're saying, let's make it all 3. So this is one way to draw a cube. On an isometric drawing, we kind of take a front point on it. And we're going to start from here, and we're going to make a cube. It's going to look a little different from what this little red diagram looks like. We'll draw it down here in green. And I'm going to draw that starting point. It doesn't matter where you put the dot, as long as you have a starting point. So I'm going to start from the dot that I put on this. And it's going to tell me I need to go 3 units this way and 3 units this way. On my paper, though, there's 1 unit, 2 units, 3 units. And we're going to go this way as well. 1 unit, 2 units, 3 units. So we're actually changing our perspective, how we're looking at this diagram. So we got 3 units either way. Now also the dimensions of the cube, it's also 1, 2, 3 up. So this is the front corner of the cube. Now it does say lines that are parallel in the real object are also parallel on the isometric dot paper. So from this point, I drew this line going straight up. This side over here is parallel to it. In a cube, that means it's parallel, and it's going to also be, so I start here, 1, 2, 3, going up. Now if I look, this bottom 3 in the red cube has to be parallel to that top 3. And if I just connect these lines, we're starting to get one side of the cube. And we can continue going from this point, 1, 2, 3, and down 1, 2, 3. So now you can start to see the cube taking place. But we need to keep lines parallel. So to this top line here that I'm retracing, I need a line parallel to it over here, and it's going to be 3 units as well. And we come down and make 3 units. There's a cube that are 3 units by 3 units by 3 units. And we use the isometric dot paper. Now that means we can make any kind of rectangular prism on here of any length. If we had something like this, and then went up, let's say 2, you could see this dot paper actually helps us draw things in 3 dimensions really quickly. Okay, so this was a simple diagram, a prism or a cube. We're going to get to something a little bit more complex here on the second page, and we're going to have to come up with a scale. And what I want you to notice from the handout that you'll get from your teacher is that I did change some units on this composite shape. I changed the bottom from a 30 to a 28. I changed the 2 9s on your handout to an 8, and this vertical line here to a 12. And it's going to become apparent why when we get to this and start drawing it. Now it does say it's drawn to scale, which means I can't draw 12 meters or 8 meters or 28 meters on this isometric graph paper. It simply isn't big enough. So we have to come up with a scale, and we've been doing a lot of these, Dr. or the drawing to the original. So my suggestion is that one space on the drawing can equal 4 meters in reality. So we're going to go through this diagram, and I'll do it in blue, and we're going to use the scale to actually shrink these units down to something I can draw. So if I started with this 28 out front and I wanted to get that drawn to scale, well, we got 1/4, that's drawing to original. On the original, I have a 28, so we're saying, what do I have to draw that? We can cross multiply, which is 28 times 1 divided by 4, or 7. So I'm going to draw this line 7 long. Now in our past lessons, we've seen that when we have a scale that's 1 to something, we can simply just divide it all by that original number. So I can go through here and divide all these by 4. So 12 divided by 4, that's 3. 8 divided by 4 is 2. This will be another 2. This will be a 2. This will be 12. Whoops, sorry, 12 divided by 4. That's a 3. And this will be a 2 as well. So now on our diagram, we're going to draw things to these blue units instead of the actual 28 meters or 8 meters. Now I'm going to say we're going to start, and I'm going to choose this corner. And we're going to start that corner down below, and we're going to draw this diagram. So if I go down a bit, at that corner, and I'm going to, something's drawn on here. At that corner, I'm just going to choose a spot for a corner. Let's say right here. Okay. And if I look at that corner, it says I need to draw 28 meters that way, or 7 dots, and 12 meters this way, or 3 dots. So we're going to do this on this sheet of paper. I'm going to go 7, 1, 2, 3, 4, 5, 6, 7. And this guy's going to go back 1, 2, 3. So that's the front corner I'm drawing on this isometric diagram. I drew this, and I drew this. Now the next thing that I can draw are all these vertical lines. That's 8 meters, this is 8 meters, and back below, or behind, sorry, is another 8 meters, which all translates to 2 units high. So I'm going to go back to my diagram and draw those vertical lines. 2 units, 2 units, 2 units. So I'm going to take this opportunity to maybe shrink this page a bit so we can see both the shape and my isometric graph paper. So now that this bottom line here is drawn, and I can see I can connect it with this line in the top diagram, I can go ahead and draw that. The front is a little different because we have this part sticking up. So if I'm from this spot right now I'm looking, I need to go 2 dots in. And on the other side, I need to go 2 dots in. So I'm going to go 1, 2, and 1, 2. So that's giving us these ledges right there. Now I might as well, from these points, do the vertical line of 3 up. So 1, 2, 3, and over here, 1, 2, 3. And now the front of this composite shape is drawn. So we can see we can connect that. Now it's a matter of drawing a whole bunch of parallel lines that'll match this diagram. So this front part here was 2, so I'm going to draw 2 back. Connect. This is still going to be 3 high. 1, 2, 3. This will connect. This will go 3 back. 1, 2, 3. And whoops, made that line a little crooked. 3 and 3 down. Now this looks almost right, but this hidden ledge here is going to come back, connecting. There we go. We have drawn this isometric diagram of that composite shape. We could go through and label these with the original dimensions. Here's the 12 meters. Here's 30 meters. 8 meters. 8, 8, and we change this guy to 12 meters. So we do have our isometric diagrams. So it's important to pick a point and then always go back on diagonals to start to get your diagram completed. Also remember, when you're setting a scale, try to look for something that will work nicely with all the numbers there. Don't choose a scale and get locked into it. Choose a scale and look at the original diagram and say, will this scale actually make my drawing easy? Is it going to lead me to having to draw something that's 2.25 dots long? Try to make an educated guess on what the best scale would be.